Hello, guys.
Hi, Irfan.
Hi, Shashi.
Hello.
Uh, just for information, Quinton would not be able to make it to today's meeting. He had some other stuff on his end. So, giving in the last meeting that we actually were discussing or talking around the doc that he published, and the expectation in the last meeting was that some people mentioned that uh, they needed more time to go through the doc more thoroughly and might need to do that. If that hasn't happened, we can postpone that particular discussion to next meeting, and we can define or decide what might be today's agenda now.
I would be interested in providing a brief walkthrough of progress so far from the Finord side. Still working through an RBAC issue around join, so demoing it, not quite yet. But there have been sort of, I think just pointing out where we're at might be useful. Like this is maybe a deeper dive. It's not going to be high level like the document that's been discussed. But to me, like some of those implementation issues are they're driving my thinking on this. I'm not really wanting to go into like high level design, like how do I handle quota, until I make sure that propagation is something we can do solidly. So.
Yeah, that seems fine to me. Actually, I was going to suggest that you might want to give a little bit of information on where you are at implementation or whatever you are doing.
Okay.
We can go ahead with that. And just to interrupt, you mentioned some issue around join. That is something you want to tell. Does that mean using Kubernetes join or
It's
it's something?
equivalent. I can maybe let Ivan talk about that since he's the one implementing it.
Okay. Cool.
Ivan, do you want to go ahead?
Sure, yeah. Well, it's actually called Kubernetes in this particular repo, but it's basically taking the same, it's leveraging the kubefed join operation and also integrating with the cluster registry to join clusters and create federated cluster objects and the necessary RBAC service accounts, secrets to be able to access all the resources in that cluster. So it's right now it's only a join operation that's been implemented. But yeah, it's basically leveraging kubefed in a Finord way with the cluster registry.
No, I was more interested in Maru mentioned some issue around it. So is there an issue which is blocking you in some way, or it's just?
Oh no. It's just in the infrastructure that we have set up for testing. There are RBAC issues that we're running into in order to kind of complete that. That's nothing's. There's no bugs or anything specific to like kubefed that are preventing us from moving forward.
Yeah, Paul mentioned that we should first go ahead with updates. So if there are issues or something, we can talk about that later. Yep. Why don't you go ahead, Maru?
Okay. So anybody familiar with the existing Federation V1 architecture will be familiar with how things are being done kind of in the Finord prototype. So you have your sync controller, you have an adapter that it's written to that's kind of like type agnostic. And then you have type-specific implementations of that adapter. And basically an adapter, it ties the controller to underlying concrete types. In the case of a secret, we've kind of broken things down. We have a template, resource, federated secret. We have a place and resource, federated secret placement. We have an override resource, federated secret override. And so the adapter basically ties, it implements all the interfaces that a sync controller needs to propagate a federated type composed of multiple resources and propagate that to member clusters, like create a secret in each cluster that is placement is defined for. So this is, I mean, this doesn't deviate a lot from what Federation V1 does, except that it's not using annotations. It's using discrete resources for different areas of responsibility, ostensibly so we can vary the implementation. As an example, the existing implementation for like overrides is very basic. We've talked a lot about having a generic like one override resource that you could use for all types, which maybe is simpler from one standpoint. But the complication is that there's issues around ensuring that there's a one-to-one mapping and defining like the best way to do a generic override mechanism, like JSON path has been suggested. Instead, I've just kept it super simple, which is what I was initially doing. Just showing the interest in making progress. So for an example, like a secret override really just consists of data and a replica. I'm just pasting things in the chat in case you're wondering that kind of point to what I'm talking about. And an override for a replica set is really just going to be replicas. So this is more in keeping with Federation V1. I mean, in Federation V1, I think the real override equivalent would be replicas. You didn't have the ability to override labels or images or anything like that. So I'm not saying this is ideal. This is just kind of like, let's get something implemented. Let's get things actually propagated to clusters and be able to vary some things per cluster. So this works today. The tests run in integration. We're not using RBAC or the service account that Ivan's working on quite yet. But the intent is that will be the way forward. It'll be a little bit more realistic. The one gotcha that I've run into in all of this has been related to defaulting. I'll try to explain this. Please ask questions or stop me if it's not clear. But in Federation V1, if I created a replica set, or federated replica set, quote unquote federated, because it was really just the cube resource created in a Federation API, it would actually be using all of the cube defaulting. Things like image pull policy for the container spec in a replica set would be set to always. As soon as we move away from that and we start defining a federated resource via like this separate template resource, which I will post to. The problem is when I create this resource in the Federation API, it doesn't know anything about cube defaulting. So any field that I do not provide as, that I don't provide in the Federation template, when it's created in the member cluster, a default will be filled in. The problem is then when I try to compare those two resources to see if I need to like reconcile, I need to send an update from the Federation API down to the member cluster. The Federation resource says, you know, image fill policy blank, and the member cluster says image fill policy always, and I have no way, unless I'm doing field level specific like defaulting in the Federation, I'm replicating exactly what Kubernetes does. The reconciler, the sync controller will say, oh, there's a difference, let me send an update. And then the next time the loop comes through, it'll say, oh, let me send an update. And so you get what I call a reconcile loop that will never end. So the way I've worked around this, because the tests are passing today, is I'm actually providing values for all the fields that could potentially be defaulted. And I can give you a link to an explanation of that, whether that's more concise than what I'm saying now. But also, if you look at this test object, all the fields that are commented with defaulted, those are all the fields that I had to provide explicit values for to avoid a reconcile loop. So the learning of this for me is that if we're not using the Cube API to define federated objects, and we're not probably going to want to copy the defaulting code, just because, I don't know, I haven't asked about that, but I'm assuming that's like it's not externalized as a staging repo today. It's not something we can vendor. We'd either have to copy it and maintain that, or we'd have to somehow, I don't know. One possible way I thought about was copying the code, and I discarded that idea. The way that I've I think the best possible solution is that the resource version would be captured for the target resource, like in the member cluster. Say there's a secret that that we're managing via Federation. I'd capture the resource version of the last update or add that I performed. And I would also capture the resource versions of the template, override, and placement that generated that resource. And then when I saw the target resource at a given version and none of the other resource versions had changed, then I would know that I did not have to perform an update. That even though the values were different, they weren't technically equivalent, it was effectively equivalent.
Maru, I think that's been a good explanation so far. I wonder if we could maybe just show some of these resources, like for example, for replica set, to show the federated replica set overrides and placement, like on a screen share for folks that are watching on the internet and may have trouble connecting the links in the chat with this convo really quick.
You're talking about like just showing all the links that
well, I think that links either to like the type definitions or example YAMLs, if you have them.
I don't think I have example YAMLs, but as code. I mean, you're talking about like examples for the federated side, not the.
Yeah, the federated side. If you don't have example YAMLs, that's fine. We could also look at the Golang type definitions quick.
So each of the is just part of testing. Each one of the. Okay, sorry, I'll share my screen. How do we share? Oh, there we go. Can you see some code?
Yes.
Yep.
Okay. So essentially, as part of testing, I have to define the set of all objects, like the template, the overrides, the placement, in order to be able to validate that it's going to propagate correctly. So this is the code representation of what it would appear as.
Is there a way to get the file name? Or unfortunately, there's no like URL. There it is. Okay. Thanks.
I don't know why it's so tiny. It's
I just, for like, if you'll want to be able to find it from watching the replay.
right. Is the chat included in the video recording?
It's not, as far as I know. I was suggesting that we could drop links into the meeting notes.
Right.
Yeah, chat is not included as part of the recording, and I'm trying to capture the notes. So Maru, you can just update the links or some whatever you've seen fit. Okay.
So here we're looking at like the component resources for a federated replica set. I've kind of started just thinking of the object that I call like federated replica set is really the template. I almost am tempted to change the naming convention so that instead of being federated blank override, federated blank placement, it would just be replica set template, replica set override, replica set, and just rely on the fact that it's namespaced in like federation.k8s.io to sort of denote that it's a federated resource. What do people think about that idea? At least in the near term.
Sorry, putting it in under which group?
So the group wouldn't change, but currently the naming convention I'm using is federated blank override, federated blank placement. But the way that I'm kind of considering in the code is, as per the code at the top of the screen share, I just call the federated replica set the template, because currently that's all it is. So I have maybe a better, the naming convention I think would make more sense would be replica set template, replica set override, replica set placement, rather than having federated prefix everything, since it's kind of implied.
Yeah, I see what you mean. That might be a slightly better option than federated X thing.
Yeah, I also think the same. The group is already defined. The API group is already defined as federated something. So rather than having federated against each resource, we can just have the actual resource name.
Okay.
Well, one of the things to keep in mind is if we are aggregating the federated API server, when you just want to get at a particular resource, you would have to then always specify the group as well. So if you wanted replica sets, but you wanted the federated version, you would have to say replica set dot, the group name.
There'd still be name differentiation. It's just rather than being federated replica set, it would be replica set template. Does that make sense?
I think you're just talking about the fields in the structure then, not the actual
No.
name of the.
No, I'm talking about the name of the type. Like at the top of the screen share, there's fed v1a1 federated replica set. I'm suggesting that federated replica set would be replica set template. So it wouldn't be replica set. There wouldn't be a direct correlation between the cube type. So hopefully it would require the group name to be specified.
Yeah, so for example, you would type cube control get replica set templates rather than get federated replica sets.
Yeah, that makes sense.
So the general form of federated type template, as you can see here, is spec just includes a template, and a template is a concrete type in some API. In this example, it's all just in the Cube API. It could as well be like an aggregated API. Placement resource, starting on line 359. All it is a list of clusters. Overrides are, as I said before, they're type specific. So in the case of a replica set, it's basically a mapping of cluster names to replica count for that cluster. One question that my prototyping has sort of raised for me is whether, like, Paul, you've talked about maps bad, lists good, or something. That's my Neanderthal version of what you were saying. But apparently there's some desire to avoid the use of maps. And to me, this is a little bit problematic, where I want only one, when I have some sort of cardinality requirement, like I only want one cluster name entry in that list. And without a map, I have to manually maintain that. And with a map, I just kind of get it for free. And I'm kind of wondering what's like, is this a case where I could use a map, or like, why wouldn't I want to use a map in this case? I can't hear you. Sorry, you're on mute.
Sorry about that. In which particular case in the placement spec?
Not in the placement spec, or maybe, no, not in the placement spec, because if I have duplicates in the list of clusters, it doesn't really matter, because when I'm applying placement, I'm only like, is this cluster name in the placement list? If it appears twice, I don't care. But if I have overrides, like starting on, an example is 377. If I have overrides and I have multiple overrides for a given cluster name, which is the one I want to apply? And given like just the last one I see, like ideally I would have a cluster name appearing only once in that list, which should seem like an ideal thing for a map.
So I will dig up the guidance on why lists of objects are preferred instead of maps, but what we could do is have a list where you would have the cluster name, and then you would have like a list of overrides within. So you'd have a type that was cluster name and then a list of overrides.
But I kind of had the same problem because if the list of overrides contains a override name to, what if there are duplicates? What if I have replicas appear twice?
Yeah, so the advantage of using a list in that case is that you can define precedence because lists have predictable iteration order and maps don't. So you could say that
the maps only have, they have one-to-one. I'm not going to have duplicate keys in my map, I guess is my point. So I'm not saying that the maps are the be all end all. It's just that I don't think maps and lists are even in contention there. Maps are.
I see what you mean. So yeah, you could have, and we actually have we have cases where we do this in the Kubernetes API where you can have a validation that enforces an invariant that a particular thing only appears once in a list.
Sorry, that's something that part of API machinery?
There are just validation implementations for Kubernetes types that do things like that.
Okay. That makes it easy then. So that's a minor thing. So I don't know, this is the rough form of what a federated type looks like today. And like I said, there'd be one additional type in order to ensure propagation in the face of default mismatch. So I'm like, replica set placement status or something, because it seems like it's kind of more of a status than something you're declaring. So before sort of fundamental types that you'd require to propagate. I'm curious. Go ahead. Sorry.
Yeah. So you talked about this defaulting thing and having to add in every sort of defaulted field.
Mm-hmm.
What do we care about the case or worry about the case now about we go to the next version of Kubernetes, another field is defaulted. Is that going to cause us problems?
So the case where, like in this example, where all the fields you see that are commented as defaulted, where I'm providing values for, this is not how I want to do it. This is how I have to do it in the absence of a reconciler that doesn't just do strict comparison. Ideally, if I have something that compares the resource versions, and if the resource versions are the same as the last time I successfully updated or added something, then I just ignore the equivalency test. Sorry, go ahead.
I guess I thought you said you did do that, not that that was a proposed solution. So then if and when you do that, then you can get rid of all these explicit fields?
Correct. And that would mean that as the defaulting change between cube versions, or if you had multiple cube versions in a federation, you wouldn't care with like if someone's using a cube version that has an image field policy of this, or configured, because that might even be something you can configure, I think, for the cluster. If you had member clusters with different configuration that provided different defaults, the federation wouldn't care. Like if you're not providing a value for a field and you know that field is going to get defaulted, I mean, you probably should document that could happen. But the synchronizer, like the propagation mechanism, does not have to worry about the implications. It's up to the user how they want to deal with it.
Yeah, so I personally think that, for example, doing something like storing the resource version of the object on the side of the Federation API in an annotation on the cluster side, so that you could have a reconciler that was able to detect, this one's in sync with me, everything's good. It's probably the way to go. And just for context, Greg, I don't think that we're intending to paint this particular thing as anything more than just like a question to figure out the answer to, rather than like representing a proposal that we do things a certain way.
Okay, yeah, sounds good.
Maru, I have one question about this defaulting. So have you seen how exactly does, say, Kubernetes replica set store the template defaults? Like Kubernetes replica set has pod template as right now what is there on your screen. So that data would be stored under the replica set, right? Not that will be stored under the replica set spec also, right?
I'm not sure I understand your question. Is it
So
that?
yeah, so let me explain a little bit. So the defaulting logic actually kicks in when the particular object details, object spec that you have specified gets stored in the etcd. So whichever version it is being used to store in the etcd, that is the default which is actually used. So in case of, for example, replica set in Kubernetes, it is storing the pod template spec also, right? So when the pod is created, that is another copy of the same stored as a pod spec, which both of them might be same today because how Kubernetes is, both of them are V1, both of them are apps V1 or whatever it is.
I honestly can't speak to that. All I know is that when I tried to propagate this specific resource without the defaulted fields,
Hmm.
the comparison was failing. And when I looked at the member clusters, all these fields were filled in as you see, because those are the default values that the particular API was targeting, was filling in. So as far as like the secondary step of like a replication controller actually creating pods, that's completely separate from this. Even before you get to that point, these fields are getting filled.
No. I was actually just curious about if you have already looked at how the defaulting of the template portion of the spec happens with respect to an actual object being created.
So you're talking about when I created when I create a
Replica
replica
set.
set in,
Yeah.
right.
What is filled in the template portion of the spec for the pod? Is it
Uh,
defaulted? It's not defaulted. Maybe I'm
all
not
of
sure.
these values are filled in. Like at the time you create a replica set in a Kube API, it does the
Mhm.
defaulting once and serializes it.
Okay. Okay.
And so
Yeah. I'll try to have a look at this a little bit and see if we can find a solution.
I mean, to me, this solution, I don't know. The challenge is that like Kubernetes works this way, and it's presumably the way that people want it to work because it's been that way for
The
a while.
only solution, clear solution I see is that if we can somehow leverage the defaulting logic which is there in the KTS, if it is somewhere outside, you mentioned that still there in staging repos somewhere.
It's not outside, and even if we were to say we wanted to pull the defaulting logic, the issue is which version do we set it to? Like we set ourselves up to having to maintain multiple versions of that and expose that whatever that to the user, and versus just allowing whatever defaulting is happening at the kube level to just do its work.
For that I can speak. That version is we ideally can match the version whichever KTS is using to store in the etcd, because that is what persists.
Right, but if I was to take this federated replica set and I was to convert it into YAML, and I was to submit the YAML to a member cluster, what should it appear as? Like, what should the defaults be? And I guess my concern is if I don't default anything, if I don't do the defaulting, then it'll be the same. Like if I created this resource without the defaulting in the Kube API via synchronization controller, it'll appear this way. And if I use that exact same YAML and put it to the cluster via kubectl, I would get the same result. That's kind of my goal here. I don't really want to have specialized behavior where it's like, if I do it through Federation, I get this, but if I do it through kubectl, I get this. To me, that
I was actually trying to indicate that particular stuff. What I meant was that in Federation, I'm not sure using this API server builder, if we have some liberty or some mechanism to do that, specify the version, for example, V1, beta 1 or V1, core V1 API, to store in the etcd. For example, this template, federated replica set template that you would store, it will persist in the Federation API server also, right? And to persist, we would be using a particular version. If we are using, say, v1 beta 1, replica set v1 beta 1, and the same version is used by K8s, then our defaults will be same. That's what I meant.
I'm not sure that's true, though.
So a couple things I want to point out, if I can just interject quickly, is that one, I think one part of the problem space that we're talking about right now is that the defaults for a particular resource are not like accessible outside of the flow where you create the resource. So for example, there is not a way, like one, validations and defaults are not exported from Kubernetes. And I've run into this, I've run into that particular issue in the context of another problem domain where we wanted to have, and we do want to have, a subset of the pod spec that you can specify on another resource. And there isn't a good way to readily consume the validations and defaults associated with those resources outside of Kubernetes. And I think that's part of the problem space we're talking about here. The other one is potential skew between versions of which defaults are applied and also probably which validations are applied in Kubernetes. And that's a tough nut to crack because it's very common for new fields to be added and the API version of a particular group not to be bumped. So for example, there are a lot of cases in Kubernetes where within the V1 resource, for example, new fields have been added and new defaults have been added, but because they're added in a backward compatible way, they don't necessitate a version bump. I think this actually ties back also to one of the foundational questions that we were grappling with when we begin discussing a Federation v2 API, which is what's the compatibility matrix between a version or a particular copy of the federated API and the targets for particular clusters. Does that make sense?
Yeah, it does make sense. And I suggest, I mean, let's not spend too much time on this. We can take it offline also.
Okay, that's fine. I do think it's a good question. And I expect that probably the fact that we're now talking about this question represents progress. I think it will be an important question to nail down because if you think about it, like the folks in the audience of this call are likely to be people that have spent a significant amount of time thinking about this problem domain. And from the last 10 minutes or so, it sounds like there's no super clear answer to this question. So if you think about the fact that as subject matter experts, it's tough to immediately say how to deal with this, we should remember that users are going to have an even tougher time for it. So part of the challenge here is to be able to make decisions about behaviors that one are intuitive to users to the extent that they, if possible, feel right at first blush and definitely feel right after you spend some time learning about the problem space. And then also, how are we going to articulate eventually to users about what these behaviors are in a way that leaves you with a good foundational understanding of how the details work, which is going to be pretty important to users.
Agree. Maru, you can go ahead, please.
I think that I'm done unless there were unanswered questions. I mean, the gist was just getting propagation working. The major challenge I ran into is around defaulting. But on the whole, I'm pretty happy with having kind of synchronization separate. I think one of the next steps in terms of prototyping is going to be implementing federated services. Ivan and I touched on that briefly this morning, but the idea would be is to separate the current implementation in V1, where programming of external DNS and synchronization of member clusters is kind of done in lockstep as part of a single controller. That we'd actually implement something separate from the sync controller that's been described today that would program the DNS in response probably to status changes versus having, and the reason being is that I think we have some users, they just want to propagate services. They want to copy the service definition into member clusters. They do not actually want to have cross-cluster DNS. And so by separating them, we kind of allow both use cases, hopefully, to be implemented. Does that make sense?
Yep, it does.
So this thread is actually reminded me of a question that Christian Bell asked in the Monday Federation Working Group meeting. And it's something that I tried to respond to at the time, but unfortunately Christian isn't here, but since these meetings are recorded, he'll be able to watch this. And
yeah, he's not in the office at the moment.
Yeah, I did want to spend a few moments, though, addressing that question. And the question was, what is the value proposition of a Federation V2 relative to one of the numerous ways that you can achieve parts of this story, like using Spinnaker or using KubeApplier, et cetera. And I think that the fundamental value proposition and goal that we have for V2 Federation API is to provide kind of a turnkey experience for folks that have use cases where they want to manage workloads in different clusters, that they do not have to string together multiple tools, and to provide that experience in a way that has that is familiar and intuitive for somebody that has an existing investment and expertise in Kubernetes. And as a secondary goal, because this is a very broad problem space, and we also want to be able, we have two kind of influencing factors. One, it's a very broad problem space, and developers tend to be very opinionated in certain cases about the APIs that they expose, for example, to users. And we want to have, we want to end up in a state where we have primitives that effectively capture the problem space that you can build higher order APIs on top of, so that if you have a great idea about, hey, I see a lot of really interesting pieces here, I've got this great idea for how I could tie them together in an API that a user would use directly, that you should be able to build that without implementing the rest of the stack. So for example, in the overview and update that Maru gave today, I think it's pretty clear that like it would be a mistake to trivialize, for example, propagating resources to multiple clusters. That's not something that I would prefer to have to re-implement if I had an idea for something higher in the stack. So we want a modular solution or set of primitives that people can use and program to, and take the parts that they want and implement the rest. On the other side, I think want to be able to take advantage of work that happens in the community. For example, propagation is something that there are a couple different efforts and tools that I'm aware of that do something very close to propagation. And there are also going to be users that might say, hey, I've already got my own propagation thing that I want to plug into this. So the goal here is to find a set of things that we can deliver as kind of a turnkey solution so that you don't have to string a bunch of things together yourself, and that it works correctly in the context of like the Kubernetes ecosystem, but that we should be able to easily drop in replacements for parts of this to leverage work that happens outside of this group. And I've been talking now for probably 2 or 3 minutes, so I'm going to shut my mouth. And I wonder if that what I've just articulated makes sense to folks. I feel like it's important to clearly communicate what these goals are and what the value proposition is, and wanted to make sure that I gave it some attention today.
Yeah, I think that makes sense. If it's something that's not written down in some form, it's probably worth having somewhere. It's harder definitely to, put it in writing because, then it has to be a higher bar, I suppose.
Yeah. I was thinking of making either a suggestion to Quinton's document or some other statement in an appropriate place, which I haven't figured out where that is yet, that articulates this so that it's clear that this is not just an effort to reinvent things that already exist.
I have a couple things to add to that. I had a lot of discussions in the aftermath of kind of the schism that occurred last year as to like, well, Federation v1 is problematic for some use cases and is unsupportable in others. How would we move forward? How would we find a solution that solves some of the use cases our customers are asking for? And the conclusions that I came to was that in order for any given like mechanism for coordinating application configuration across clusters, you need certain capabilities, like for one, maybe namespacing, so that you're not having configuration stepping on itself. Maybe auth and auth-c, so that you have some degree of control over who's doing what. And also validation of configuration, like if I have some YAML, how do I know that it's valid? Providing easy, early feedback to users is helpful. And that's not saying that, the CI-based, more CI-centric mechanisms aren't useful, but in the case where you want people to be able to ad hoc create and define, the configuration they want to propagate to multiple clusters and have it access controlled and have it validated, you could replicate what the Kube API does, or you could just use the Kube API. And I think that there's already existing solutions like KubeApplier that kind of fit the bill in terms of I just want to apply some configuration. You could reproduce what the Kube API does today, and you could layer it on top of that. And that's a solution. It's just one, like, from a kind of an economic perspective, I've kind of come to the conclusion, I think it makes more sense to just reuse the Kube API for use cases that require those properties. If you don't need that, if you're happy doing something simpler, if your use cases are restricted to the degree that you can afford the validation, authentication, or whatever, or you don't need it, then Federation maybe isn't a good fit. But for enterprise users where they do have sort of policy-based ways of working, I think that that's important. And in that case, Federation does make sense. Or a Federation-like API does make sense.
Yeah, I mean, that was a good overview, Murray. I wanted we still have 15 minutes, and I had 2 more items which I thought might be useful for discussion, or maybe we can initiate the discussion in today's meeting and continue forward some other in the next or some other further meetings. So one is the second point that you mentioned was about the authentication or authorization. So I actually mentioned one comment on Quinton's talk also, which is towards the end of it, saying that we maybe need some discussion around this, uh, keeping that V2 implementation in perspective. Like whoever was associated with V1 earlier, we do remember that one of the unsolved problems there, or the problem which is pretty difficult to solve, is which user, or as which user Federation should talk to the member clusters. So given the V2 in perspective, does it still remain the same challenge, or is it different? For example, we have talked about two different kind of approaches. The pull based approach might be simpler to implement in terms of in terms of the same aspect. One other point which I wanted Maru you to take 5 minutes, which you can take before that, is maybe 5 minutes to just tell about how exactly you are handling the testing in the current implementation that you are doing.
Okay. I think like I'll do the testing second, if that's okay.
Okay.
I think like there's two sort of auth and auth sort of contexts, and one is in the Federation API, and that's like, you know, who can create a federated secret, or who can manage like placement rules. And that to me kind of ties into, if we wanted to implement something policy based, where an administrator would say, you know, you have to, if your application has these characteristics, you can only go into these clusters. And for some environments, maybe they want to enforce that. And so having RBAC enabled, like in the Federation API, that's more what I was talking about. What you were talking about was, how does Federation, like a synchronization mechanism or propagation mechanism, how does it interact with the member clusters? And for now, I'm kind of assuming that the status quo of, we have a single service account that has all the access it needs to the underlying clusters to, you know, create resources and update resources, delete resources. That's the way you do it. If you want, in a push-based model, we're not going to approach having to have separate service accounts that would have limited access, like say to a single namespace. At least in the near term, the reasoning behind that is that as soon as we start limiting access to service accounts on a per namespace basis, that prevents us from listing all resources in a useful way. Like if you want to list all resources, not just like on a per namespace basis, that just isn't something that's supported via API machinery today. So if we wanted to allow restrictive like service accounts or restricted service accounts, it would effectively mean that for each namespace in a member cluster, you would have to do a separate watch. And that just adds so much complexity, I don't think we want to touch it. And so in cases where we, like when we have users, I don't think it's if, I think when we have users come to us and say, we want to have a restrictive policy, we only want to have, you know, this namespace federated or these namespaces federated, that's when we would probably recommend a pull model. And we would need a configuration generator, probably that generated like something for KubeApplier, and then they would run KubeApplier in their clusters, and they would only have access to change. Because I don't know, it kind of puts the onus on the in-cluster reconciliation mechanism. But I kind of feel, at least for now, like we just don't want to add complexity before we've sort of fleshed out a solution that's generally useful. And then when there's special cases like I want a restrictive like access to the underlying cluster, we can target it sort of in an ad hoc basis rather than having to build it into the core solution. Does that make sense?
My point was not necessarily to arrive at a solution right now. My point was only to, I think it is an important point that we need to discuss, and it ideally should have some attention from all of us, and maybe we should set aside some time or one of the meetings to have a definitive discussion on that. What we are, we all think that is right to do as of now, and if there is a problem in future, then there is some alternate for that also.
Yeah, I think it makes sense to have a deeper discussions about this. The one thing that jumped out at me was about like, oh, well, maybe users are going to have different service accounts to access different clusters, but the service account for each cluster would be, able to access the whole cluster.
Yeah, and that would be possible today.
Okay.
Because the authentication, like the credentials for a given network cluster are completely independent from the credentials for any other cluster. So it can vary however the user needs it to vary.
Yeah, there's also potentially a use case for delineating access to a particular cluster along namespace lines, in the sense of I could easily imagine a user saying, I don't want to have a highly privileged service account that has like cluster role bindings that make it able to create replica sets in every namespace. I want to differentiate the service account used by a propagation mechanism potentially to along namespace lines, so that I can give individual service accounts access to the namespaces that they should manage, and that's it. But I would prefer not to design that without having somebody articulate it as I want this first. I'm just saying there's probably permutations of things that we can't think of yet that users will want.
That's been a requested feature in the past, and I believe there's an issue in Federation V1, targeting Federation V1. It talks about that requirement. And I mean, I've had discussions with the Google folks last year about exactly how we would do it. And as I said, the way the API machinery works, it would require like watches on a per namespace basis rather than on a cluster basis. And so it may prove like a problematic thing to do depending on the number of namespaces you have to watch. And so if we were going to implement it, I think it would kind of have to be like an either or thing, like maybe on a per type basis, but like, I don't think it's like, oh yeah, we just want to build in that you can have this granularity, because the granularity really does have a cost.
Yeah, it does have a cost, and it has, it's an implementation cost and a cognition and education cost for users. In the case of like differentiating the service account by namespace that's used to communicate with the cluster, I could see potentially something that for like everything but secrets, you might use a service account that can just see everything to do the observation, and then differentiate rights by service account.
Mm-hmm.
But
I guess, yeah. I guess my instinct in the near term is that that would be something like to delegate to a pull sort of model. Partly because then people kind of have an easy choice, and partly also because if I was to have a lot of watches, it would probably make more sense that I would have those watches locally. So if I had a ton of connections, they weren't subject to the vagaries of like the connectivity between Federation and cluster, they would be local.
yeah, yeah, it seems like we're in a lot of ways talking about about properties of propagation, right?
Yeah. I don't know. I should apologize. It's kind of hand wavy. I mean, if a user requires it, and it doesn't really matter where we implement it. We just have to implement it. We just have to make sure that it doesn't, break other use cases.
So I'm a little curious about what kind of use cases, for example, Red Hat's users might have where Federation would have a wide enough access to clusters. Would that be only admin use cases in that case?
Sorry, Irfan, you kind of were very muffled in the middle of that question.
Oh, what I was asking is, I was a little curious about what kind of use cases, for example, Red Hat's customers might have for this scenario. Would that mean that most of the use cases are only admin related use cases, which might have enough access to federated clusters? Was I clear this time or still? Hello?
I'm sorry, I got a message that distracted me. Yeah, I think 3 minutes remaining is probably not enough time to get into that question.
Okay, yeah. Let's cut it short here. And I would probably see that in one of say future meetings. I'll bring it up again, and doesn't block anything else. Means we have time for discussion, and we probably don't have anything else to discuss, and I'll bring this up. Maru, would you want to spend say 4 minutes about the test now?
Sure. So the testing is pretty similar to what was done in Federation V1, in that there's kind of the same sort of CRUD tester framework, only instead of targeting a single resource, it's targeting like the template, the placement, and the override for a given type. The one sort of enhancement that I'm working on in concert with SIG testing is creating end-to-end tests that can be like, if they're provided, end-to-end test that if it's provided a kubeconfig, the test will run against that kubeconfig. But if you don't provide a kubeconfig, it will actually deploy an integration test cluster, very similar to what an integration tests currently use. But the goal there is maybe removing the idea of an integration test and moving towards an integration test that can run against a test managed cluster or an unmanaged cluster, one for which a kubeconfig is just supplied. And the work in SIG testing that's ongoing is kind of defining a common interface for instantiating different types of test clusters, so that it would be possible to say, I want to run this suite and I want to run it with a hollow node cluster or a Docker and Docker cluster, and have it automatically do that with no changes to the tests. But I mean, if you're familiar, I guess like the for Irfan, I mean, you're familiar with the CRUD tester and how that works. For anybody who isn't familiar with that, for Federation V1, as part of sort of modularizing the synchronization mechanism and using adapters to integrate with the underlying types, that's the implementation side, but then there's kind of a test side as well that uses those same adapters to drive like CRUD testing in the API. Can I create a resource? Does it propagate the way I expect? You know, can I update it? Does it propagate? Can I delete it? Does the deletion propagate? And so it means that when you define a new federated type, you define the adapter and you register it. Like the way that the controllers work is you actually register the adapter and the kind, and the controller manager actually instantiates a controller for every single registered type. And so the testing works very similarly, where it'll actually iterate through all the registered types, instantiate the controller necessary against the API that's already deployed as part of fixture, and then it'll run a test that's keyed to that specific type. And so the part of the goal here, there's kind of two goals in development, prototyping. One is creating something that works with, like flushes out the primitives that have been discussed. But the other part is lowering the cost of implementing and maintaining a new federated type. We don't want to have to create, these new types and then create a new controller and new tests. Instead, we just create the new types, create the adapter for the type. We get the controller and we get the tests basically for free. We're not testing obviously specialized behavior, but all of the baseline stuff that you just need to be there is going to be validated. Any questions?
Yeah, that seems quite okay. Just one last question about that. So you mentioned that you are working with TestInfra to have some kind of mechanism where a managed cluster could be brought up. For example, you said maybe a Docker and Docker or something like that. So that is only the interface defined to bring up such a cluster. That's what TestInfra you might be working on, or something else.
Currently, the focus, and I can can share the doc. In
Yeah,
chat.
yeah. If there is some reference, it will be.
So the
handy.
starting point is really just to find the interface that like a test framework would use to bring up like a test managed cluster. And there'll be some prototyping work around like actually integrating something maybe Docker and Docker based. But I mean, really, it's not super complicated. The motivation for this is, as the document, I think that's included in the document I just linked to.
Did you share it, or who's it shared with?
Oh,
Okay.
sorry, it's shared with SIG testing.
Oh, okay.
I guess I could share it also with SIG Federation if that's useful. Hold on. Or SIG multi-cluster rather.
I need to drop for another meeting. We're at time, so thanks everybody for joining. See you next time, and I'm going to drop now. See ya.
So,
Oh.
so if anybody's interested in discussing this further, I mean, it's pretty high level today. The goal is just laying the groundwork for out-of-tree efforts to have common test infrastructure. Currently, if you're in Kubernetes, there are there's a test framework, there's lots of ways to bring up clusters, there's lots of different integration test fixture, there's actually way too many, but at least they exist. And the problem for anything outside of the tree, including like Federation v2, because Federation v1 just vendors Kube, is how do we have shared infrastructure for testing? So the first step is creating kind of a way of having test managed clusters, have an interface where tests can sort of not care about the implementation of how it's brought up, and all they're going to get is like a kube config and maybe an indication of how the cluster is configured. Longer term, maybe tests would define what characteristics they require of a cluster. So for example, if I'm running a test that really only requires an API, I would have some sort of annotation on the test that indicated, requires : API or something. And I would have another test that, I require workloads. I actually need nodes that are going to run pods. If I run those tests together, the test runner would sort of aggregate all of the test requirements and determine that the common denominator is, I need a test that has an API and runs workloads, and I would deploy a full cluster with Docker and Docker. But if I was to just run the test that just required an API, I could actually run a test cluster tailored to that test. And so that I would minimize the amount of sort of infrastructure I require to run any given test. The other thing that I'm kind of experimenting with in the context of Fnord is manage an unmanaged cluster. Well, maybe I would like to run, we ran into a problem trying to debug, or like with RBAC, as Ivan mentioned. It's possible, we're going to try to do, since he's running into trouble, is we're going to run against an unmanaged cluster, but we're going to disable the controller manager for Federation and actually run those in memory, and it'll be a flag. So essentially, if you wanted to run the controller for, secrets in memory, you could deploy like a Federation, but you could disable like the secret controller as part of the deployment, and then you could run it as part of the test and debug it. And it would be very trivial to do. It would be something that anybody could do rather than having to like hack code or configuration. But the goal is kind of striking a balance between tests that run really well in continuous integration and automatically, and tests that are useful for developers that can serve as kind of jigs for debugging. Because I want both to work, but as a developer, I really want things that are useful to me. I don't want to just throw tests into the cloud and have them run. I want to actually be able to run them locally and introspect on what's going on. And so my goal in participating here is to make sure that we do have a developer-focused result rather than just being something that, like, don't get me wrong, like the work that Test Infra does is amazing. Like Kubernetes lives and dies by its CI, but we definitely need more of a developer focus on the testing side. So it's not just writing tests, but actually using them as a tool. Anyway, that's it.
Okay. But whatever you explained, Maru, that sounds really promising, exciting. I mean, we have faced
Exciting
so
is
many
testing
issues.
easy.
if it's getting implemented by itself. I just saw the document. Something is assigned to you. I think that implementation is assigned to you. One of the implementations or something.
Yeah, I'm just going to experiment with integrating with an existing like Docker and Docker solution.
Okay.
Because as per the document, there's kind of I think there's some sort of, oh, did they actually remove it? Huh, no, there's like a test cluster config, like how you would define the configuration for provisioning a cluster. And we kind of have to flesh out something that's common across different implementations. I mean, things like number of nodes is pretty easy, but like, which controllers do I want to run and what configuration do I want them to run with? We need a common way of representing that across different mechanisms for deploying test clusters. So my goal is kind of just trying to work through deploying like something Docker and Docker based and figuring out like what configuration representation will be useful to do that, and then I'll try to apply it to different mechanisms.
Cool. Yep. And apologies to rest of the folks. We took a little more time than usual.
Yeah.
Yeah. So see you in the next meeting Monday.
Cool. Yeah. Oh, yeah, I'll be there.
Okay.
Thanks all.
Okay. See you.
Bye.